find the critical t-value, and I'm going to pull it down here. Find the critical t-value that corresponds to a 95% confidence interval. So that means the middle represents 95%, or 0.95. The formula sheet says that both tails together are going to be what? So if my middle is 95, what are both tails going to be? Who? 0.05. And we don't want both tails. What do we want? One tail. So what do we have to do? Divide by 2. So I'm going to do that 1 minus the 0.95. So 1 minus the 0.95 gives me the both tails. So this tail and this tail is going to be 0.05. So that gives me both tails. And I divide by 2. So each tail is going to be what? 0.025. So this tail, which is the tail that I need, is 0.025. So on my formula sheet, I'm going to have to use 0.025 and 16 degrees of freedom. So if I come down to 16 degrees of freedom and I come across to 0.025, what is my answer going to be? 2.120? That is what I have. And that is off table 7. Now, the only difference over here is because they didn't give you the degrees of freedom, you're going to have to subtract 1 off of it. So to get your degrees of freedom is going to be n minus 1. So you're going to do 20 minus 1, so your degrees of freedom are going to be 19. Let me copy and paste and put that a little bit lower just to give you, let's pull, copy, minimize, paste. So if I'm doing this one, I've got my 90 in the middle. So I do the 1, I do the 1 minus the 0.9, which is 0.10, which is both tails. I divide by the 2, so that gives me 0.05. So I'm going to be using 0.05 and 19 degrees of freedom. Right? Go with me? 0.05 and 19 degrees of freedom, what would my answer be? $1.729. So for this one, it would be n minus 1 to get my degrees of freedom. So 16 minus 1, so my degrees of freedom are going to be 15. And then this is going to be 95%. So 1 minus 0.95 is 0.05. And divide that by 2 is going to be 0.025. So 0.025 and 15 degrees of freedom. 2.131? 2.131. So just remember, if they give you the degrees of freedom, use it. If they give you the n, you've got to subtract your 1, and they're probably going to have both answers there to make sure that you know what you're doing. All right. Let's see what we have next. This is number 28. Construct a confidence interval. right, we're going to stat edit and type in our data. Go ahead and do that. Stat edit and type in our data. Doesn't matter how we type it in, as long as it's all there. Remember, when we do the confidence interval, you are doing that confidence interval off that mean and getting that standard error, so you've got to have that mean and that standard deviation, which we don't have. So to get the mean and the standard deviation, we've got to go to 1-var stats. So we're going to go to 1-var stats to get your mean and your standard deviation, because they didn't give it to us. So we're going to do 1-var stats to get your mean and your standard deviation. So we're going to do stat calc 1-var stats. And the only reason we're going here is to get our mean and our standard deviation. So we need our mean, we need our standard deviation, and it's also going to ask us how many pieces of data we have. And then finally, we're going to go to stats, over to test, and we're going to choose number 8, which is t-interval. Oops, wrong button. I'm going to do stat, over to test, and I'm going to go down to number 8. And I'm going to choose t-interval. Now, the good news is, when I did the 1-var stats, it sucked everything over. It sucked over my x-bar, it sucked over my sx, and it sucked over my n. The only thing that it didn't suck over is my confidence interval. So the only thing that I have to fill in is the 0.95. Everything else got sucked over. So the only thing that I have to change is the 0.95, and then I'm going to hit calculate. So this one I had to change to 0.95. The other ones got sucked over from the 1-var stats. So my confidence interval is going to be 1035.8 to 20. My phone is talking to me. 10477.2. That is my 95% confidence interval. Yay? So I did stat test number 8 t-interval, and I had to do the 1-var stats because they did not tell me my mean, my standard deviation. I could have easily gotten my 10 things from counting pieces of data. Do you want to do another one of those? No, not that one right there. Here, we can play with this one. So the question's going to say, construct the confidence interval. And again, when you go to the confidence interval, when you go to the t-interval, it's going to say, what is your mean? What is your standard deviation? And you're going to say, holy crap, I don't have my mean and my standard deviation, which means you're going to have to go to your 1-var stats to get that. So the first thing we do is we do stat edit, and we type in our data. Then we go to 1-var stats, and we get our mean and our standard deviation and our pieces of data. And then we go to stat test, and we go to number 8, which is t-interval. And again, I make this look easy. You've got to practice the steps to know what am I going to go to what problem. And do not practice them in order. I totally typed those in wrong. Should have been 28. Should have been 28. That should have been 26. Alright, so that's my stat edit. And then I'm going to do one bar stats, and I'm only doing one bar stats because they did not give me my mean and my standard deviation. And I do not have to do L1 and L2 because I only have one list of data. So I'm looking for my mean, I'm looking for my standard deviation, I'm looking for my pieces of data. And then I'm going to go stat test, and I'm going to go down to number 8. And I still have 95% confidence interval because it was in the last problem. And then I go down to calculate. So my answer is going to be, that is my confidence interval, 31.896 to 44.604.
Which test did you do for
The T interval number 8,
that? Okay.
stat test number 8, the T interval. Alright. Number 29. Off of your review sheet. Sure that's the one I'm doing. No, I'm doing number 30. I'm doing test a hypothesis about a population proportion. Test a hypothesis about a population proportion. Describe the rejection region using the classical approach and find the test statistic for p-hat. Oh, hold on, I'm doing 2 different ones. Test the hypothesis, and I'm doing number 31. Alright, so this is going to be 2 different problems. One is going to talk about the hypothesis region, and one is going to talk about the test statistic. So we're going to do 2 different things. Alright, so let me just steal one and put it on another page so I can have some paste. Alright. The drug Lipitor is meant to reduce cholesterol and LDL cholesterol. 19 out of 863 patients taking it complained of flu-like symptoms. Suppose that it is known that 1.9% of patients taking competing drugs complain of flu-like symptoms. Is there evidence to conclude that more than 1.9% of Lipitor users experience flu-like symptoms as a side effect of a level of significance of 0.01? So, for this one, and it talks about the rejection region. So that means we need to do H0 and H1. H0 and H1. We know that our H0 is going to be equal. What is it going to be equal to? Get your whoop whoop on. Who? Okay. What is the next one gonna be? Says more than. Is my test left-tailed, right-tailed, or two-tailed? It is going to be right-tailed. They told me that that is equal to 0.01. What is my X and my N going to be? N's how many people I surveyed? 863. And how many people had the flu? 19. That's where we get our p-hat or our point estimate. Okay. Now, let's start drawing a cute little picture, which is the way I like to do it. Let's go to our table. Let's look at table 5. Table 5, bottom right. We have an alpha of 0.01 and it is right-tailed. So, table 5, bottom right corner. Table 5, bottom right corner. We have a level of significance of 0.01 and it is right-tailed. What number am I going to use? 2.33. So the number that I got off that sheet is 2.33. So that means that's like my data point. Okay, now I'm going to go to stat, over to test, and down to number 5, which is the one proportion z-test. Now, if I pull it up, it's going to tell me what I need to fill in. One proportion z-test, number 5. It's, not number 6, Jim. Stat, test. It's going to tell me what I need to plug in. So what do you think my p-hat's going to be? 0.019. What is my X? 19. Good. What is my N? 863. Is it going to be not equal to, less than, or greater than? Greater than. And so now we are going to calculate. Now, what we got from this is we got our, use a different color, our Z. Now, because this was a right-tailed, this was our reject area, and this was our not reject area. So we want to know, where does this point end up? Does it end up in our rejection area, or does it end up in our not rejection area? So when I go to put that point, 0.64, that point, 0.64, is a not reject. So we are not going to reject the data. Now, this is the classical approach. The other approach is to look at our P. Is our P, is our P lower than our, why can I not get my thing? Is our P less than our alpha? Is our P lower than our HO? So our P is 0.25. Our P is 0.258. Our alpha is 0.01. Is your P lower than your HO? If your P's lower than your hoe, your hoe must go. So you gotta keep it, do not reject it. Because it is not. So either way, it's telling us to keep it. Let's look at another one of those, because those are kind of tough. Let's do, eating together. Let's do that one at the bottom. I'll let you try this one. In December 2001, 38% of adults under the age of 18 said that their families ate together 7 nights a week. 403 of the 1122 said that they ate together. Has this proportion of the age of 18 who eat together? So you need to do your ho and your high. Go to your table, figure out whether we reject it or whether we keep it. And this is 2 different questions on the test. What is our H naught? 0.38. And we're doing P, so I shouldn't have that. I should have P. All right. So P is, sub 0 is equal to 0.38. And what's the other one going to be? Less than, greater than, or equal to?
Less than.
Has it decreased? So we're going to do less than 0.38. What kind of tail is it? Left tail. So that's going to be shading to the left. What is my X? 403. What is my N? 1122. And what is my level of significance? 0.05. When I go to table 5, it is going to be a level of significance of 0.05, and it's going to be left-tailed. So when I go to table 5 and I look at both of those things, a 0.05 and a left tail tells me what number to use. What am I going to use? Negative 1.645. So negative 1.645 is what I'm going to put here, negative 1.645. And it is left tail. So this is going to be my reject, and this is going to be my no reject. So now I am going to go to stat test number 5, one proportion z-test. What am I going to put in for p sub 0? 0.38, and my x is going to be 403, and my n is going to be 1122, and I'm going to highlight the less than. So when I come over here and I do stat test number 5, I'm going to do 0.38, 403, 1122, and I'm going to do the less than. And let me pull that down so you'll have it in your notes. And then when I hit calculate, this gives me two things. It gives me my z, and my z is right, ooh, is that right?
Yeah.
Yes? All right, my z is negative 1.43 or 436, and then my p would be the alternative method. Is p less than alpha? So p is 0.08. Is that less than 0.05?
No.
No. So either way, it's a no reject. No reject there, no reject there. Cool? All right. Now, this is going to be 32 and 33. 32 and 33. Not with the highlighter. 32 says find the test statistic for T, and 33 says identify the p-value for a hypothesis test T. Now, remember, t-test have a standard deviation. So you know that it's going to be a t-test if it has a standard deviation. The test that we just did, the p does not, or the z-test does not have a standard deviation, but the t-test has a standard deviation. So these two had no standard deviation, so we're not going to use those. We're going to come down and I'll do a couple of these so we can practice. ACT college entrance exam determined that a score of 22 is ready. A random sample of 200, and this one has a standard deviation. That's what's telling you that it's a t-test. So let's do the H0 and the H1. We are doing a mean, we're not doing a p, so I'm going to do mean. What does my mean equal? What was the average test score? 22. The average test score was a 22. Now, for these, remember, they didn't do like the last ones. The last one said you're gonna make a score less than or you're gonna make a score greater than.